Good everyone, I welcome you back to Global Education Zone. And today, in this episode of Data Processing for SS3, we are going to be dealing with indexes. Now, indexes has to do with those kind of features of our data processing processes that help us to access data in an easier and faster way. Now, basically, in order to explain indexes very well, indexes are basically when you have, just imagine a library of books. Now, indexes are those notes. If you've ever been into a library, you have some kind of placeholders. So they are kind of like those placeholders that are that are taped to the front of each section of the library. Now, each of those sections has the text. So the section containing books on mathematics or algebra, they have a particular placeholder. Now, those placeholders, we can imagine them to be our indexes. So the function of an index is simply to make data retrieval and information retrieval to be a more smoother and faster process. That's how I want you to see it. And like it or not, in your computer, many things are going on in the background which you don't know. And one of these is the indexes. So there are many ways your computer makes use of indexes to make file retrieval and storage to be a more rapid process. Now in this video, we're going to be looking at these different ways your computer stores data and makes it easier for you to access. Now, what's an index? An index can be seen as a special lookup table that the database search engine can use to speed up data retrieval. So if you want to simply put it, yeah, an index is kind of like a pointer to data on the table. So an index is a database. An index inside a database is very similar to an index at the back of a book. So for example, if you want to reference all pages of a book that discuss a certain topic, you first refer to the index. That index will tell you which particular the location of that topic in that book, and even in a library. So, and it lists all the topics alphabetically, and they are then referred to one or more specific pages. So if you've ever read a book to the end, I know that you have, because for you to be watching this video, you must be a very very studious person. Now, if you've ever read a book from cover to cover, you notice that at the end there are all these glossaries. So they are kind of like the alphanumeric. They are kind of like the alphabetical order of important terms and all the rest. So they give you all the important terms that were discussed in that book. So that is simply how I want you to view an index. An index is kind of like a glossary of your files in your computer. So, and these indexes, they make it easier for us to integrate and operate our computers. Now, indexes are automatically created when primary keys and unique constraints are defined on table columns. Now, I want us to extrapolate that our knowledge of indexes and come into the sphere of data processing. Now, in data processing, we make use of database management systems. So that include Microsoft Access, Microsoft and all those other database management systems like MySQL, SQL Server, and all the rest. Now, each of these, they have their own index system. Now, this index system, they are automatically created when you create a primary key, and that primary key is a unique identifier. If you don't understand the concept of primary key, just imagine the name or given to a particular person. So imagine that two people are not allowed to bear the same name, and that name of the person is the unique property of that person. Now, that is the same way I want you to see an index. It's kind of like the unique property of each part. So they are automatically created when you have primary keys. And so these primary keys, they are kind of like the mechanisms that enable these indexes to function. So basically, if I were in the crowd of 1,000 people now, and you happen to know my unique name, my surname, and my middle name, and then you just conjure everything up, and then you speak everything out. So there would be this there would be this resonance in my head. I'll be like, wow, someone is referring to me somewhere, and then I will look up and I will be able to communicate with you, right? So that is similarly how this thing works in your computer. So your computer just looks up its file and say, oh, like I know the name of this particular data, so it just looks it up, and then it just calls out that data, and that data will just raise up its hands, and you have your communication between you and your computer, so on and so forth. So that's just an analogy of how it all works. Now, the concept of an index is to make it easier for the database management system to release data to an index to provide fast access to the rows in a table. So basically, in a database management system, you remember we have rows and tables, and then this we have fields and we have column values for those fields. Then we have records which are corresponding to the horizontal rows on a table. Now, there are different classifications of indexes we will be discussing. We have the clustered versus non-clustered indexes. And then we also have another type of indexes called dense versus sparse index. So I'll be talking about them in detail today. So sorry, in I'll be going over them in some detail rather. Now, a clustered index is kind of index that sorts and stores the data into the data rows in the table of views based on their key values. So it stores based on the key values, and these are the columns included in the index definitions. There can only be one clustered index per table because the data rows themselves can be sorted in only one order. So because you can only sort your data in only one order, you only have one clustered index. So they are kind of like unique indexes. Now we also have the non-clustered index. They have a structure separate from the data rows, and a non-clustered index contains a non-clustered index key values, and each key values entry has a pointer to the data row. So index non-clustered index, they can have different for a particular table. Then next we have the dense versus sparse. So the dense index is a kind of is a file with a pair of keys and pointers for every record in the data file. So you can see the dense index is kind of like a coordinate, a coordinate way of reference to data. You can an example of that is basically when you make use of in a GPS, you can have the coordinates of a particular location. So basically, you can call that a kind of index that returns two values, an x and a y value. So then when you match them together, you have kind of like a dense index. So then we also have the sparse index, which is a file with pair of keys and pointers for every block. So basically, you have blocks of data, not just a record. You have a block of data. So a sparse index, and you can see it kind of like a grouped index. So every key in this file is associated with a particular pointer in the block. So in clustered indices with duplicate keys, the sparse index points to the lowest search key in each block. In index, records are created only for some of the records. So these are the four ones we're dealing with today, and we also have other parts of this topic, which we're talking about primary and secondary index. So a primary index is basically an index that contains the key field of a table, whereas a secondary index is used to index fields that are neither ordering key nor key fields. So a primary index is used when you have the key fields. They are corresponding with the key fields, and those key fields are kind of like the main fields, the ID, the identity of each record in the table. Them, or rather, the secondary index, they are used to index fields that are neither ordering fields. They are not key fields, so they can just call them candidates keys and so on and so forth. Then now this on the screen here we have an interlinkage of table. This is kind of a an entity group of entities and their relationships. Now this kind of setup is called a composite search key. So the search key for an index can contain several fields, and these these keys are called composite keys. So because they are different and they are concatenated, they are also known as concatenated keys. And for example, let's consider a collection of employees record. So on this table we have employees records with fields name, the age, and salary stored in sorted order by name. Now, the diagram below, this diagram you can see on the screen now, it illustrates the difference between a composite index with key age, S sal, and a composite index with key sal. Age, an index with key age, and an index with key sal. So basically, you can see there are different kind of indexes. You have an index with age and salary on this on the top right. You have an index with only age with on the top rather on the top right. Then we also have an index with salary and age on the bottom left. Then an index with ordinary salary on the bottom right. So these are different ways you can actually draw up values of each of these employees on this table. So for example, when you have a particular one like Bob, you can just make use of the index on the top right. So that is the age index. So you can use that. You can pick out the employee with a value of 11. So you can pick out that as that's that would be CAL. That would be Carl. So that's the unique individual that has an age of 11. So these are basically used for data retrieval, and I hope you enjoyed this short episode on indexes. Now, if you have, you can also try the questions on the screen in this episode. You are asked to explain indexing, and you are asked to discuss different types of indexing. So you can also comment about this topic if you have further knowledge of it. So, but this is as far as I can go in this episode. Thank you for watching, and I hope to see you in the next episode.